All right, this is a video of the slides we're going to show on week 3, day 1. So the introduction slide, by the end of class, students will be able to use the original equation or original steps to write an inverse equation. And the second thing, interpret inverse equations in a real-world situations. So the warm-up is Ms. Lane was practicing finding the inverse equation to prepare for today's lessons. To check if her equation was right, Ms. Lane plugged 2 into the original function. She got a -5 as an output. Ms. Lane then plugged -5 into the inverse function she had written and got a 9 as the output. Did Ms. Lane find the correct inverse equation? Why or why not? This would be incorrect because if you input a number into a function and get an output, and then take this output and put it into the inverse, you should end up with a 2. So the answer here is no. So no. The output of the inverse function, f inverse of x, should be 2. All right, so reminders are to take the checkpoint quiz by Tuesday night if you have not done so yet. And also do the assignment. So the assignment that's on the module. Which will be a good practice for the assessment that we're going to do at the end of the week. All right, so a function is a rule that relates input to an output. So start with the number and multiply by 2. So if you have the number, it's x. You multiply by 2, take the result and subtract 5. And then square the result. And then the output would be, or the original function would be f of x equals 2x minus 5 squared. All right, and here's the answer key here to that. So the inverse algorithm would be take the square root. I'm going to just abbreviate it like that. And then take the result. And then add 5. And then take the result again and divide by 2. Okay, so the inverse function would be you have some number x, take the square root, and then you're going to add 5 to that, and then take that result and divide by 2. So the inverse equation then would be square root of x plus 5. The 5 is outside the radical. So make sure when you're writing a square root in a function or the inverse of whether this number here, some operation is under the radical or outside. So in this case, it's outside. So the inverse function, square root of x plus 5 divided by 2. All right, so when given an original function, try to find the inverse function. A good tool to use is the OT chart, original inverse, or a do undo chart. So the original would be take the cube root. So take the cube root. I'm just going to abbreviate this. Add 1 and then divide by 5. So we did this in class before. This is 1, 2, 3. And then let me, we did this in red, so let me get red there. So 1 would be multiply 5. 2 would be subtract 1. And then 3 would be cube. So if I were to write the inverse function here, start with an x and multiply it by 5, so 5x, subtract 1, and then cube, so cube the whole thing. So you can stop the video if you need to spend some extra time looking at that. All right, so, and then in class, we're going to go to breakout rooms and have you try this with a group. And so when you get out of the breakout room, these are the 2 problems that you should have worked on. So here's the original and then the inverse. So if I would number these 1, 2, 3, 4, then over here 1 would be subtract 6, and 2 cube root, and 3 add 7, and 4 divide by 2. So the original equation would be f of x equals start with the number x, double it, subtract 7, and then cube the result. and add 6. And then the inverse function, you take x, and then you're going to subtract 6, and then take the cube root of both of those things, add 7, and divide by 2. Okay, so you could just do the inverse right here on the inverse algorithm, and then so double it would be divided by 2, but then you would have to number uh, these the other way. So you would have to, if you, in other words, if you put right next to this one, the inverse would be subtract 6, then you would start down here and go 1, 2, 3, 4. So that's the way we did the undo table in class, but you can do it either way. I prefer to do this, so it started here, and then I went up here first, and then down. But in class, we started here, worked our way up. Just did the inverse of each one of these first 4 steps, and then numbered them from bottom to top. And, all right, so this one, the original algorithm, they give the equation, so you're going to add 5. So first, you do what's inside the parentheses first, so add 5. And then second, square. And then multiply by 7/3. All right, so the inverse then, and like I said, I'm going to start up here. 1 is to divide by 7/3, which is the same as, so this might be a little confusing, but divided by 7/3 is say be multiplied by the reciprocal. And then 2, take the square root, and 3, subtract 5. So the inverse of g of x, g inverse of x, or I can just say this, the inverse of g of x, will be 3/7 x, and then take the square root, and then subtract 5. Okay. All right, Mr. Wiggins is looking to set up a delivery service for dog food for his dog, Mamba. You found a service that offers food for $2 a pound and $5 shipping cost. So write an equation to represent this. So let me use blue again here. So 2 times the number of pounds, whatever pounds is, we're going to call that x, plus 5. So here, They did a little bit different. Instead of saying f of x, they said cost is equal to 2 times the number of pounds plus 5. And then Mr. Wiggins made pounds the independent variable here, P, because he was thinking about how much Mamba eats. His wife, Dr. Wiggins, said they can only spend $50 on dog food. So she wrote an equation where the cost is the independent variable. So in other words, she did the inverse function. So what's the relationship? These are inverse functions. If they can only spend $50, how much? How many pounds can they order? So if you plugged into the original or this one, it really doesn't matter. So let's do the second one here. So P is equal to 50 minus 5 divided by 2. So 45 divided by 2 is 22.5 pounds. Or if you plugged in here this one, the same thing, you'd be solving for P. So if you plugged into this one, 50 is equal to 2P plus 5, then you'll get the same answer. So you subtract 5 first, and then divide by 2. So you could use either equation, but the second one, if you plug in the costs right here, get the pounds. This one, if you plug in for cost here, you have to solve for pounds. All right, and then the next problem, the cross-country bake sale. Each item costs $75, but everyone who buys something must make a $5 donation. Write an equation that represents the total money. So if I said f of x again is equal 0.75x plus 5. So on the next slide, they might have used different variables there, but so they used 0.75 times the item number of items plus 5 is the cost. So Mr. Krause just was handed some money, but forgot how many items the person ordered. Write an equation to represent the total number of items based on how much money was given. So I is going to be the cost minus 5 divided by 75 cents per item. And so if Mr. Krause was given $9.50, how many items did the person buy? So it's going to be $9.50 minus 5 divided by 75 cents. So we got $4.50 divided by 75 cents would be 6, I believe. So 6 times 75 would be 420 and 30 yet. So 6 items. All right, so the checkpoint quiz is due Tuesday night, and the problem set that the writing inverse functions is due Wednesday night. The deadline is Sunday night. So on each assignment, we'll have a due date and a deadline. So after this deadline right here, the assignment goes away. You can't click on it anymore. You're going to have to email us and say, I went past the deadline and I didn't do the assignment. So then we can either send you that or talk about it with you. So we're going to send individual students an assignment if they missed the deadline. And so you want to use this problem set as a way to study for the quiz on these first 5 student learning tasks that we did. All right, I'm gonna stop the video here, and then you can look at this. We'll go over this in class. I'm not gonna post this until both classes see the work on this.